Surface chemistry deals with the phenomena that occurs on the surface or interface. The surface or interface is the area of contact between the two different phases. For example, solid in contact with liquid or solid in contact with gas. In both the cases, the area of contact between the two different phases are called surface or interface. Many important phenomena are noticeable near the surface. They are adsorption, corrosion, electrode processes, dissolution and crystallization. In this session, the important features of adsorption can be discussed elaborately. Adsorption is essentially the surface phenomena. From the study of surface tension of liquid, it is known that the surface of a liquid is in a state of strain because of unbalanced forces. These unbalanced forces are also called as residual forces. The same is true with the surface of solid also. Because of these residual forces that exist on the surface of a solid that tend to attract the molecules that come in contact with it. These attracted molecules persist only on the surface and never go deeper into the bulk of solid or liquid. So, the concentration of the molecules that are present at the surface are more than inside the bulk. The phenomena of accumulation of any molecular species at the surface than inside the bulk of a solid or liquid is known as adsorption. Due to adsorption, there is a decrease in residual forces on the surface. This in turn reduces the surface energy also. Adsorption is an exothermic process. That is, adsorption accompanies a decrease in enthalpy of the system. This means delta H is negative. The negative value is very high because it is an exothermic reaction. Adsorption also changes the adsorbate from more random gaseous state to less random adsorbed state on the solid surface. The randomness decreases. The decrease in randomness confers the decrease in entropy of the system. As the entropy of the system decreases, change in entropy would become negative. The delta H and delta S both are negative during adsorption process. We all know that the change in free energy of a system is expressed by the equation delta G is equal to delta H minus T delta S. If delta G is negative, the process is called spontaneous process. If delta G is positive, the process is called non-spontaneous process. In the case of adsorption, delta H and T delta S that are at the right hand side of this equation are negative, and delta H is having a very high negative value. This confirms that the delta H minus T delta S will give us a negative value. Thus adsorption is a spontaneous process. We all know that from the experiments, heat of adsorption per mole of adsorbate goes on decreasing because of adsorption. Delta H becomes less and less negative as the adsorption proceeds further and further. Ultimately, delta H would become equal to T delta S. This makes delta G equal to 0. At this stage, the equilibrium is reached. Now, we are going to see some important terms that are used in surface chemistry. Adsorbent. What is adsorbent? The substance on whose surface adsorption occurs is called adsorbent. The surface on which the adsorption occurs is generally called as adsorbent. The surface on which the molecules that come in contact the surface is called adsorbate. What is adsorbate? Adsorbate is any substance that can come and contact with the surface and result in adsorption. That is called adsorbate. For example, ammonia is adsorbed by charcoal. In this case, charcoal is the surface. The surface is adsorbent, whereas the ammonia is adsorbate. That is, the molecule that come in contact with the surface is called as adsorbate. So, the ammonia is adsorbate and charcoal is adsorbent. The specific surface area is defined as the surface area per gram of adsorbent. If the specific surface area is very high for an adsorbent, that adsorbent will become an active adsorbent. The specific surface area of different adsorbents vary greatly. So, it depends upon the nature of the adsorbent. Some of the examples we can see here which are having very high surface area. They are crystalline zeolite, active charcoal and silica gel. To understand adsorption very well, it is compulsory to know the phenomenon called absorption. What is absorption? It is the phenomenon in which the substance is not only retained on the surface, but also it is getting distributed throughout the body of the solid or a liquid. This is called adsorption. It is a bulk phenomenon. Some of the examples for absorption are water vapor absorbed by anhydrous calcium chloride, ammonia mixed with water. When sponge is put into water, it takes up the water completely. Some of the examples for adsorption are water vapors adsorbed by silica gel, ammonia adsorbed by charcoal. Finely divided solid, when it is mixed with a gas of low pressure, the pressure is found to decrease. It is also due to the adsorption process. Let me discuss about the difference between adsorption and absorption. The accumulation of adsorbate that takes place near the surface is called as adsorption, whereas the substance is getting distributed throughout the body in the case of absorption. So, adsorption is a surface phenomenon because it occurs one near the surface alone, whereas absorption is a bulk phenomena because the substance is getting distributed throughout the bulk. In the case of adsorption, equilibrium is attained instantaneously, whereas in the case of absorption, equilibrium will be attained very slowly. The adsorption isotherm takes this shape when we plot the pressure versus adsorption, whereas absorption isotherm will give a straight line and crosses through the origin. Sorption is the process in which both absorption and adsorption takes place instantaneously. Example for sorption is taking up of gases by zeolite. Occlusion. The sorption of gases by metals is known as occlusion. Positive adsorption. If the concentration of the adsorbate is more at the interface, the adsorption is called positive adsorption. Negative adsorption. If the concentration of the adsorbate is less at the interface, the adsorption is called as negative adsorption. Desorption. It is the reverse of adsorption, that is, removal of adsorbed substances from the surface of adsorption is called desorption. There are so many factors that are responsible for the variation of adsorption of gases by solid. They are nature of adsorbent, surface area of adsorbent, nature of adsorbate, temperature of the system, and pressure of the system. Let me see one by one. Nature of adsorbent and surface area. The surface area of adsorbent greatly influences the extent of adsorption. If the surface area is high for an adsorbent, then the amount of substance is getting adsorbed is also high. The subdivision of adsorbent, that is powdering of adsorbent, increases the specific surface area and hence the magnitude of adsorption also increases. This is the reason why the finely divided metals and porous substances like zeolite provide high specific area. Nature of adsorbent. So the amount of gas adsorbed by the solid adsorbent also depends on the nature of the gas. If the nature of the gas is liquefiable more readily, that is having very high critical temperature, they are adsorbed more easily. The gases which are non-liquefiable, that is which are having very low critical temperature, they are not absorbed easily because non-liquefiable gases have greater van der Waals forces of attraction. Therefore, the gases which are having very high critical temperature or which are more readily liquefiable has greater extent of adsorption. Effect of temperature. We all know adsorption is an exothermic process. Hence, the rate of adsorption increases with decrease in temperature. Effect of pressure. The magnitude of adsorption depends on the partial pressure of the gas. Adsorption of the gas leads to decrease in pressure. Hence, magnitude of adsorption will increase the increase in pressure and vice versa. Adsorption process can be classified into two types. They are physisorption and chemisorption. Physical forces that holds the adsorbate and adsorbent. This is called physisorption. Chemical bond that holds the adsorbate and adsorbent. This is called chemisorption. In chemisorption, there is a new surface chemical compound is formed. The other name of physisorption or van der Waals adsorption or physical adsorption. The other names of chemisorption or chemical adsorption or activated adsorption. The forces that are responsible for physisorption are dispersion force, electrostatic force, short range repulsive force, and polarization. The chemical forces responsible for chemisorption. It is very strongest force involved. Differences between physisorption and chemisorption. Physisorption is generally existing in a very weak force. It is an exothermic process. Chemisorption exists with the help of a strong chemical bond, and it is also an exothermic process. The physisorption is having the heat of adsorbent which is very low, that is approximately less than 40 kJ per mole. Whereas in chemisorption, the heat of adsorption is of the order of 40 kJ to 400 kJ per mole. Physisorption takes place at ordinary temperature. Chemisorption occurs at high temperature. Physisorption is existing with a weak force, as well as the attachment between the adsorbent and adsorbate is very weak. Chemisorption takes place with a strong chemical bond, and the attachment between the adsorbent and adsorbate is firm. Physisorption is instantaneous and the equilibrium is reached rapidly, and it is reversible in nature. Chemisorption may be slow or rapid. That depends on the nature of the chemicals used. The equilibrium is established very slowly, and it is an irreversible process. Chemisorption is very specific, whereas physisorption is non-specific in nature. If the temperature of the adsorbate is below the boiling point, this will enhance the physisorption, whereas high temperature is required to execute chemisorption. Chemisorption occurs even above the boiling point of the adsorbate. Effect of pressure on physisorption. Increase of adsorption rate occurs with the increase in pressure. Chemisorption is favored if the pressure is very high. A small change in pressure will not affect the progress of the chemisorption. In physisorption, multi-layers will be formed. In chemisorption, only monolayers are formed. The activation energy is not essential in the case of physisorption. Chemisorption has significant effect over activation energy. Chemisorption occurs with the help of activation energy. The desorption is the reverse of chemisorption. The desorption of physical adsorption takes place, and the graph is represented using this figure, whereas chemisorption takes this graphical representation. There are 7 types of adsorption isotherms were reported so far in the case of physisorption. Some of these were well explained by Dept equation. In the case of chemisorption, a typical single adsorption isotherm is represented as shown in the figure. In this, as the pressure increases, the adsorption also increases gradually. Ultimately, it reaches a saturation point. Even after that saturation point, the pressure increases, the adsorption doesn't change. It reaches a limiting value. Adsorption, especially physisorption, is a general phenomena, and it takes place at all instances. Chemisorption occurs very rarely. It is not a general phenomena. It occurs only if there is a compound formation between the adsorbent and adsorbate is observed. Physisorption is a function of coverage of surface area. That is, if the surface area increases, physisorption also increases. Whereas in the case of chemisorption, there are specific sites which are called as active sites. These active sites will adsorb the adsorbate and execute the process. Types of adsorption curves. The amount of gas adsorbed on the surface of the adsorbent depends on the pressure and temperature of the system. This can be mathematically represented by the equation x by m is a function of pressure and temperature, where x is the amount of gas adsorbed on m mass of the adsorbent at that particular temperature and pressure. There are three types of adsorption curves are noted. They are adsorption isotherm, adsorption isobars, and adsorption isosteres. The first one is adsorption isotherm. In this, temperature is maintained constant throughout the process. So, the adsorption depends on the pressure of the system. In the second one, the isobar, the pressure is kept constant. In this, the pressure is kept constant throughout the process and the adsorption depends on the temperature. In the third type, that is adsorption isostere, the adsorption is kept constant and the variation of pressure with temperature is noted. That leads to adsorption isostere. There are 7 types of physical adsorption isotherms are reported so far. The type 1 adsorption isotherm takes this graphical representation. This is a typical Langmuir isotherm. The adsorption is monolayeric. The figure shows that a saturation point is reached, which means that after a certain value of pressure, there is no change in adsorption. Even the pressure is increased. Example of this type is adsorption of nitrogen on charcoal at minus 195 degree Celsius. Type 2, in which the multilayer of physisorption is noticed, that is, the point at which the multilayer starts is the point called B. At this point, the monolayer formation stops or completes and the multilayer formation occurs. Example of this type is nitrogen adsorption over silica at minus 195 degree Celsius. Next one is type 3. This type of physical adsorption occurs on porous materials. No transition point is observed in this isotherm. The isotherm confirms that multilayer formation starts even before the monolayer formation completes. Example for this type of curve is adsorption of bromine or iodine vapors on silica gel at 79 degree Celsius. Type 4. This type is a physical adsorption that takes place on porous material, followed by capillary condensation. It is the duplication of type 2 isotherm. It has a tendency to reach a saturation state after the multilayer formation. So the curves look like this. Next one is type 5. This isotherm is also representing the adsorption, physical adsorption of porous material. In this, the multilayer formation is noted from the beginning itself. Example for this type is benzene adsorption on ferric oxide at 50 degree. Type 6. This type of adsorption is expected for non-wetted adsorbent system. Type 7. This type also occurs in non-wetted adsorbent system. In this, the saturation point or saturation vapor pressure is reached. There are three types of adsorption isotherms are reported. They are Freundlich adsorption isotherm, Langmuir adsorption isotherm, and Dept adsorption isotherm. For a gaseous adsorbate adsorbed on the solid adsorbent or liquid adsorbent. Freundlich adsorption isotherm. The Freundlich adsorption isotherm is an empirical equation that relates adsorption and pressure. The equation is x by m is equal to k p power 1 by n. That is, x by m is the mass of the gas adsorbed on m mass of the adsorbent at a particular pressure P, where k and n are constants here. Taking log on both sides of the equation, this equation can be converted to log x by m is equal to log k plus 1 by n log p. This equation is for gaseous adsorbate. If the adsorbate is a liquid, then this equation takes this form, that is x by m is equal to k c power 1 by n, where c is the concentration term, that is concentration of the solution. Testing of Freundlich equation. Method 1. For this testing, log form of the Freundlich equation was taken. By plotting log x by m versus log p, we will get a straight line. From the straight line, the slope of the system can be calculated and the intercept is also noted. From this graph, the behavior of adsorption isotherm is represented and the value of 1 by n that lie in between 0 and 1. Two cases were observed in this Freundlich equation. The first case in which 1 by n is kept 0. So the pressure term is become constant. So constant into constant, that leads to constant. So adsorption is independent of pressure term. So adsorption is independent of pressure of the system. That is the case 1. If 1 by n is 1, then there is P power 1. That is pressure power 1. So pressure exists. It doesn't disappear. So adsorption depends on the pressure of the system. So adsorption depends on the pressure of the system means directly proportional to pressure. If the pressure of the system increases, the magnitude of adsorption also increases. This method 2 was saturation test method, in which the x by m, that is adsorption versus pressure, will give us a curve like this. As the pressure of the system increases, it reaches a saturation point. That is, adsorption reaches a saturation point and doesn't change further. That point is called as saturation point, which infers that at high pressure adsorption doesn't occur. So the explanation for this saturation point cannot be explained by Freundlich adsorption isotherm, which infers that the adsorption isotherm fails at a high pressure. Limitations of Freundlich adsorption isotherm. It is purely an empirical relation. It has no theoretical background. And the constant K and N are not temperature independent. And the equation is valid over a certain period of pressure only. So we have to move for other type of isotherm. Applications of adsorption. Adsorption finds innumerable applications in industries as well as in the laboratories. Some of the important applications are listed here. Synthesis of ammonia, methanol, hydrocarbons, manufacture of hydrogen, nitric acid, synthetic petrol, sulfuric acid, vegetable oil, etc. As well as in medicine field, it is applicable in curing the disease, especially the drugs or poisons that are adsorbed on the germs to kill them. In concentrating the ores, used as masks, in creating very high vacuum, and also used as indicators. Adsorption also used to check the evaporation of water. And in chromatography, in recovering and concentrating the vitamins, adsorption is highly useful. It is used as lubricant and also used for softening of water. Let me see in nutshell the things that we learned from this session. Introduction about adsorption. That is, adsorption is an exothermic process. It is a spontaneous process. And important terms that are used in adsorption: adsorbate, adsorbent, sorption, occlusion, etc. What are the various factors that are affecting the adsorption? Classification of adsorption. They are classified into physisorption and chemisorption. Difference between them. Then types of adsorption curves and types of adsorption isotherms, Freundlich adsorption isotherm, and the applications of adsorption. Let you enjoy learning. Thank you.